Hey everyone, and welcome to this explainer. Today, we're unpacking one of the absolutely most fascinating economic mysteries of our time. You know, every time you map a route, pause a video, or look up a recipe online, you're generating this invisible exhaust of digital information. The entire modern AI economy is literally built on this digital exhaust. But here's the thing. How do those microscopic, everyday digital interactions actually translate into the astronomical, multi-billion-dollar valuations we're seeing today?
Okay, let's dive into this. For years now, we've all been told that data is the new oil, right? And because of that, we've just kind of assumed that big tech companies operate as massive surveillance brokers, harvesting our private lives and auctioning them off to the highest bidder just to serve us targeted ads. But in the AI era, that's actually not what's driving the billions. So if they aren't directly brokering your personal identity, where exactly is all this cash coming from?
Well, the reality completely debunks that common data broker myth. You see, raw, unorganized personal data is chaotic. It's heavily regulated. On its own, it actually has almost zero financial utility for an AI developer. Instead, the reality of the AI business model is entirely different. They aren't selling your data. They're using your data to train systems. What they're actually selling is cognitive automation software to enterprises. Simply put, they are selling the intelligence derived from the data, not the data itself.
Section 1. The Digital Refinery, Transforming Data into Intelligence. To really grasp this, we need to completely shift how we visualize these companies. Stop thinking of them as data brokers and start thinking of them as digital refineries. Think of raw data as, well, digital iron ore. If you just have a massive pile of iron ore in your driveway, you can't exactly drive it to work, right? It has to be refined. So first, AI companies ingest this raw data. Then, they refine it inside hyper-controlled AI data centers through this intense computing process called training, where the machine builds a mathematical model of human language and reasoning. Finally, that newly minted intelligence is packaged into a usable, predictive product. Economic value is only created once that metamorphosis is complete.
Section 2. The revenue engines. Who is actually paying for this?
Now that we know exactly what these companies are manufacturing, which is intelligence, we really need to figure out who is opening their wallets to buy it. And there are three main pillars generating cash here. First up, we've got consumer subscriptions. Think of people paying $20 a month for ChatGPT+. That's great, but the true financial drivers, those are the next two. Enterprise contracts and API usage fees. The modern AI economy is fundamentally built on business-to-business transactions. Fortune 500 banks and global logistics firms are the ones paying massive premiums for enterprise copilots to do things like draft legal documents, write code, and manage entire supply chains.
So the crucial point is understanding exactly how these businesses are built. Because AI models don't read text the way you and I do. They convert absolutely everything into numerical representations called tokens. And in the API world, a token is the fundamental unit of billing. Developers pay this microscopic fee for every single word or fragment their software queries.
The math here is incredibly simple, but man, is it lucrative. The total cost a developer pays is basically just the input tokens multiplied by the input price, plus the output tokens multiplied by the output price. Now, why does this matter to us? Because every time a developer builds a successful app, say a really popular customer service chatbot or a legal research tool, using an AI company's API, that app essentially becomes a silent revenue partner for the AI company. As that app grows its user base, the API consumption scales right along with it. The AI company makes more and more money without ever having to acquire a single new customer themselves. It's brilliant.
Section 3. The cost of intelligence, the crushing reality of compute.
But here is where things take a crazy turn. Consider this absolute paradox. How on earth is it mathematically possible to bring in $6 billion in just 4 months and still struggle to turn a profit? Seriously. To answer this, we're going to look at a fascinating case study from Epoch AI on the economics of what we'll call the GPT-5 bundle, which basically represents the flagship period of a state-of-the-art model.
Walk through this balance sheet with me because it is wild. Over a 4-month period, the top-line revenue hits a staggering $6 billion. Amazing, right? But look at where that money immediately goes. $4 billion is instantly swallowed up by inference compute that's literally just the cost of running the model for users. Then you've got $1 billion for high-end engineering talent, $500 million for sales and marketing, and $200 million for admin. The money is flowing out almost as fast as it's flowing in. And this brilliantly illustrates just how insanely lopsided the expenses are. Look at that massive 70% slice of the pie. That right there is the physical footprint of AI. We're talking about sprawling, massive data centers packed with tens of thousands of specialized chips that cost tens of thousands of dollars each. We're talking about heavy-duty liquid cooling infrastructure and utility bills for raw electricity that literally rivals small cities. The physical hardware required to generate this intelligence is absolutely crushing.
So when you add it all up, the estimated operating margin in this specific case study is actually negative 5%. No way, right? But yes, once you account for these staggering operational costs and the fact that these companies often have revenue-sharing deals with their cloud providers, the actual profit left over is razor-thin, or in this case, entirely negative. And keep in mind, this doesn't even fully account for the billions of dollars spent on research and development before the model was even launched.
Which brings us to a massive R&D dilemma. You really have to think of frontier AI models as rapidly depreciating infrastructure. A company might spend $5 billion developing the smartest model on Earth, but within months, a rival lab releases something just slightly smarter. Suddenly, the users migrate, and the value of that multi-billion-dollar investment is basically wiped out. They have an incredibly short, high-pressure window to recoup their costs before their infrastructure essentially becomes obsolete.
Section 4. The scale for survival. The path to profitability.
Let's move to and see how this builds. So how do they survive this? Well, it all comes down to massive, unprecedented scale. You see, the economics of digital intelligence follow completely different rules than physical manufacturing. If you build a physical car, you pay for steel and labor for every single unit that rolls off the line. But software is different. You spend $1 billion to train the model once. Sure, connecting it to that very first customer costs $1 billion, but distributing that exact same model to 100 million users, that costs almost zero in additional development. They survive by spreading those massive fixed training costs over a truly global user base.
But to reach that kind of global scale, they still need physical servers. And that is exactly where strategic cloud partnerships come in, like OpenAI's landmark deal with Microsoft Azure. Microsoft provides the massive compute infrastructure. Essentially, they're providing the kitchen equipment required to run the restaurant in exchange for a sizable slice of the revenue and equity. Because without this kind of arrangement, AI companies simply couldn't survive the upfront capital required to build these digital refineries.
So what's the long-term game plan here for actual profitability? It really boils down to these three key strategies. First, they are aggressively trying to drive down the cost of inference through algorithmic efficiency, basically just making the models cheaper to run. Second, they're locking in long-term sticky enterprise contracts so that businesses build their entire workflows around the AI. And third, they are introducing features like memory. Think about it. If an AI system remembers you, your preferences, and your company's data, the cost and headache of switching to a rival becomes incredibly high. They're trying to shift away from this massive R&D burn rate to creating sustainable high-margin ecosystems.
Ultimately, investors are willing to stomach these multi-billion-dollar losses today for one single reason. They believe that, quote, in the long run, AI will become so broadly effective and so cheap, capturing trillions of dollars from labor automation. Investors aren't looking at today's razor-thin margins, they are looking at the ultimate prize. They are betting on capturing literally trillions of dollars from global labor automation.
Which leaves us with this final, really provocative thought to ponder. We are quite literally watching the most capital-intensive industrial process in human history unfold in real time. So the question is, will these digital refineries successfully transition into highly profitable empires that conquer the global economy? Or will the crushing physical cost of compute and electricity bankrupt them before they even cross the finish line? It is absolutely the ultimate high-stakes race. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.